Question number 20. If x plus iy is equal to a plus ib upon c plus id, prove that x square plus y square whole square equal to a square plus b square upon c square plus d square. Now here squaring on both sides, we get x plus iy whole square equal to a plus ib upon c plus id whole square. So this becomes x square plus 2xy I plus iy whole square equal to square and square root get cancelled, a plus ib upon c plus id. Now here I square becomes minus 1, so x square plus 2xy I minus y square equal to a plus ib upon c plus id into c minus id upon c minus id. Now see, multiplying this, a into c minus id plus ib into c minus id upon c into c minus id plus id into c minus id. So this becomes AC minus ICD plus IBC minus I square BD upon C square minus ICD. Sorry, here instead of this we can use A plus B, A minus B rule. So this becomes C square minus ID whole square. So this becomes C square, I square is minus 1. So this becomes plus D square. Similarly, this AC and this I square is minus 1, so this becomes plus BD. Here I will take I common, so I will write down BC minus CD upon C square plus D square. So this is the expression here for x square minus y square plus 2xy I is simply AC plus BD upon C square plus D square plus I into BC minus CD upon C square plus D square. Equating real and imaginary parts, we get x square minus y square equal to AC plus BD upon C square plus D square, and 2xy equal to BC minus CD upon C square plus D square. Here AC PD comes, here BC CD is coming, so I think I did something wrong. So just want to cross check. A into IB, BC and BD, it's correct. See, here it should be AC plus IAD. Okay, so this become minus AD. This is also AD. This becomes AD. Now we know that what we want to verify. We want to verify x square plus y square whole square is that terms. So we know the formula x square plus y square into whole square is x square minus y square whole square plus 2xy whole square. Expand it, you will get this. And this is the LHS side of our equation. So I will write down LHS equal to this equal to that. So this is, sorry, Now see, I will write down this equation 1. So from 1, what will be the things? This becomes AC plus BD upon C square plus D square whole square plus 2xy is a BC minus AD upon C square plus D square whole square. This is from 1. So on squaring, this becomes A square C square plus 2ABCD plus B square D square. Denominator becomes same. So I will write down this like this plus B square C square minus 2ABCD plus A square D square upon C square plus D square whole square. So this plus 2ABCD minus 2ABCD get cancelled. Now what remains is A square C square is here and A square D square is here. So I will write down those in combination A square C square plus A square D square plus here it is B square C square plus B square D square upon C square plus D square whole square. Take A square common from this term. This becomes C square plus D square plus take B square common from this term. This becomes C square plus D square upon C square plus D square whole square. Now take C square plus D square as a common. Remains A square plus B square. I can write down this like this C square plus D square into C square plus D square. This get cancelled out. What remains is A square plus B square upon C square plus D square, that is equal to RHS. See here, we want to prove that this is getting proved. Okay, now next 21. If A plus IB equal to 1 plus I upon 1 minus I, then prove that A square plus B square is equal to 1. So here we will rationalize 1 plus I upon 1 minus I into 1 plus I upon 1 minus I. So numerator become 1 plus I whole square upon this becomes 1 minus I square, 1 square minus I square. So numerator becomes 1 plus 2I plus I square upon this becomes I square minus 1 because I square is a minus 1. So this becomes 1 plus 2I minus 1 upon 1 plus 1. Okay, so this plus 1, sorry, this plus 1 minus 1 get cancelled. This is 2I upon 2. This 2 get cancelled. Therefore, for A plus IB equal to this simply I. So I will write down 0 plus I. Therefore, on comparing real and imaginary part, we get A equal to 0 and B equal to 1. Now therefore, now here LHS is simply A square plus B square. I'll write down this equation 1. So A is 0 square plus B is 1 square and this is from 1. So this is simply 1 equal to RHS. Okay. (22) show that this term is real. So term is square root of 7 plus I square root of 3 upon 7 root 7 minus I root 3 plus root 7 minus I root 3 upon root 7 plus I root 3. So we will cross multiply this. These are the same terms. So this becomes root 7 plus I root 3 whole square plus root 7 minus I root 3 whole square upon root 7 whole square minus I root 3 whole square. On expansion of this term becomes root 7 square plus 2 times root 7 into root 3 I plus I root 3 square plus root 7 square minus 2 root 7 into root 3 into I plus I into root 3 whole square whole divided by square of root 7 is 7 minus I square into 3. Okay, so this becomes, this term gets cancelled with this term. So here remains 7. I square is minus 1, 7 minus 3. Again there remains 7 minus 3. Upon this 7, I square is minus 1, minus minus plus. So 7 plus 7 is 14 minus 6 upon 10. 14 minus 6 is 8. 8 by 10. 2 4s are 2 5s are. This is 4 by 5, which is a real number. So that term is a real term. Okay. Now 23. If x plus iy whole cube is equal to y plus vi, then show that this. Okay, so we will take the cube of this term. This becomes x cube plus 3 x square iy plus 3x iy square plus iy whole cube is equal to y plus vi. Now this becomes x cube plus 3x square I square is minus 1, so this becomes 3xy square. I cube is a minus I, so this becomes yi equal to y plus vi. Since I square equal to minus 1 and I cube equal to minus I. Now see, therefore this is y cube I minus I. Therefore this becomes x cube minus 3xy square. Okay, and after taking I common, this becomes 3x square y minus y cube equal to y plus vi. On equating real and imaginary parts, we get x cube minus 3xy square is equal to y and 3x square y minus y cube is equal to v. This is equation 1. These two are equation and it is as a equation 1. Now what they have asked now, LHS is simply y by x plus v by y. So y is what? Y is x cube minus 3 xy square upon x plus v is 3x square y minus y cube upon y. This is from 1. Okay. Now take x common, remains x square minus 3y square upon x, x cancelled, plus y common, 3x square minus y square upon y, y cancel, it becomes x square minus 3y square plus 3x square minus y square, x square plus 3x square is a 4x square minus 4y square. So 4 is common, remains x square minus y square, and that is the RHS, hence proved. Okay. Now next question, 24th. Question is what? Find the value of x and y which satisfy the following equation: xy belongs to real number. First, x plus 2y plus 2x minus 3y I plus 4i equal to 5. Okay, therefore this becomes x plus 2y plus, again I will take I common from this side, so this becomes, or you can write down 2x minus 3y I equal to 5 minus 4i. Now on equating real and imaginary part, we get x plus 2y equal to 5 and 2x minus 3y equal to minus 4. Now, okay, multiply equation 1 by 2 and subtract at equation, subtract it at from equation 2. Okay, so equation 2 is 2x minus 3y minus 4. After multiplying, equation 1 by 2 is becomes 2x plus 4y, 2x plus 4y equal to 10. After subtraction, sign changes. This plus 2x minus 2x get cancelled. Minus 3 minus 4 becomes minus 7y equal to minus 4 minus 10 becomes minus 14. Therefore, y is equal to minus 14 by minus 7. Therefore, y is equal to 2. Put y equal to 2 in equation 1. We get x plus 2 into 2 equal to 5. Therefore, x plus 4 equal to 5. Therefore, x equal to 5 minus 4. Therefore, x is a 1. So, this is the answer. Therefore, x comma y is simply 1 comma 2. This is the answer. Now, second question from 24th. X plus 1 upon 1 plus I plus y minus 1 upon 1 minus I equal to I. Cross multiplied x plus 1 into 1 minus I plus y minus 1 into 1 plus I upon 1 square minus I square equal to I. X into 1 minus I plus 1 into 1 minus I, here plus y into 1 plus I, this is minus 1 into 1 plus I. Okay, if you don't write this one, it's okay. I wrote it down for your understanding purpose. This becomes 1, I square is a minus 1 is equal to I. Therefore this x minus xi plus 1 minus I plus y plus yi minus 1 minus I upon this becomes 2 equal to I. Minus of minus 1 is a plus 1. Now see, this plus 1 get cancelled with this minus 1. Now what remains is x plus y, here x plus y again. Okay, now this is minus xi plus yi minus I minus I, this is 2i equal to 2i. This 2 gets multiplied with that, therefore this becomes x plus y minus, the here remains minus, take minus as a common, it becomes x minus yi equal to minus 2 go to that side and this becomes 2i plus 2i, that is x plus y minus x minus yi is equal to 4i. On equating real and imaginary parts, we get x plus y. Okay, so here we can write down 0 plus 4i, x plus y is a 0. Okay, therefore x is equal to minus y, and second is a minus x bracket minus y is equal to 4. So this become minus x plus y is equal to 4. Oh, I think something is minus x plus y, x is minus of minus y. Okay, now this is 2. Put x equal to minus y in equation 2, we get this is minus, again x is a minus y plus y equal to 4, therefore this becomes y plus y equal to 4, this becomes 2y equal to 4, therefore y equal to 4 by 2, therefore y is simply 2. Put y equal to 2 in equation 1, we get x equal to minus of 2, therefore x comma y is simply minus 2 and 2. This is the answer. Now third one, x plus iy upon 2 plus 3i plus 2 plus I upon 2 minus 3i equal to 9 by 13 1 plus I. Okay, now cross multiply this term, therefore x plus iy into 2 minus 3i plus 2 plus I into 2 plus 3i divided by 2 square minus of 3i square equal to 9 by 13 1 plus I. So multiply that terms x into 2 minus 3i plus iy into 2 minus 3i plus 2 into 2 plus 3i plus I into 2 plus 3i upon 2 square is a 4. I square is a minus 1, that's why it can become plus. And 3 square is a 9 equal to 9 by 13 1 plus I. So 2x minus 3xi plus 2yi minus 3y I square plus 4 plus 6i plus 2i plus 3i square upon 4 plus 9 is a 13 equal to 9 upon 13 1 plus I. Now this 13 and this 13 get cancelled. When any one of 13 goes to the other side, okay, that goes to the numerator. Now see, okay, here simply single y term is not existing, so I will write down 2x minus 3xi plus 2yi I square become minus 1, this becomes plus 3y plus 4 plus 6i plus 2i, and this becomes minus of 3 equal to 9 plus 9i. Now this 2x and 3y I write down in one place. 2x plus 3y, here I will take I as a common from these two terms, okay, plus here minus 3x plus 2y I. Now here this 4 minus 3 is simply 1. 6i plus 2i is 8i equal to 9 plus 9i. So this becomes 2x plus 3y plus minus 3x plus 2y I equal to, here this 9 minus this 1 plus 9i minus 8i. So this becomes 2x plus 3y plus minus 3x plus 2y I equal to 8 plus I. Okay. On equating real and imaginary part, we get 2x plus 3y is 8, equation 1 minus 3x plus 2y equal to 1. Now if I will multiply equation 1 by 3 and 2 by 2, see, multiply equation 1 by 3 and equation 2 by 2, 2 by 2 and 2 by 3, then add. Okay, so we are multiplying this equation by 3, this equation by 2. So what will become 6x after multiplying by 3. Okay, simply I will write down this as a 3. Don't write it in your answer by 2. I am writing it for your understanding purpose. 6x plus 9y equal to 24. Now this becomes minus 6x plus 4y equal to 2. So then adds, that's why this 6x minus 6x gets cancelled. 9 plus 4 is 13y equal to 26. Okay, therefore y is equal to 26 by 13, therefore y is simply 2. Put y equal to 2 in equation 1, we get 2x plus 3 into 2 equal to 8. So this becomes 2x plus 6 equal to 8. Therefore 2x equal to 8 minus 6. Therefore 2x equal to 2. X equal to 2 by 2. Therefore x equal to 1. Therefore xy is 1 comma 2. Okay. This is the solution of third one. Now fourth. If x into 1 plus 3i plus y into 2 minus I minus 5 plus I cube equal to 0, find x plus y. Okay. Therefore, x plus 3xi plus 2y minus yi minus 5 I cube is a minus I equal to 0. Therefore, this becomes x plus 2y plus I is, okay, here I will take I common, this 3x minus y I, remaining terms goes to the other side, this becomes 5 plus I. Now on equating real and imaginary parts, we get x plus 2y equal to 5 and 3x minus y equal to 1. Okay. Now multiply equation 2 by 2 and then add with equation 1. Okay, x plus 2y equal to 5, multiply this by 2, so this becomes 6x minus 2y equal to 1. Sorry, not 1, this is 2. So this plus 2y minus 2y gets cancelled. This is 7x equal to 7. Therefore x is 7 by 7. Therefore x is 1. Put x is equal to 1 in equation 1. We get 1 plus 2y equal to 5. Therefore 2y equal to 5 minus 1. Therefore y equal to, this becomes 4 by 2. Therefore y is 2. Now we want to find out x plus y. Here they told us to find out x plus y. So x is 1 and y is 2. Therefore x plus y is simply 3. This is the answer. Now next one, fifth. X plus 2i plus 15 I raised to 6 y equal to 7x plus I cube y plus 4, find x plus y. Therefore this becomes x plus 2i plus 15. This is I raised to 4 into I square into y equal to 7x. I cube is simply minus y plus 4. So this becomes x plus 2i. I raised to 4 is 1, I square is minus 1, so it becomes minus 15y equal to 7x minus yi minus 4i. Therefore, this is x, this comes to here, it will become minus 7x minus 15y, that is simply 7x, okay, 15y Now this y terms comes here, that yi equal to minus 4i, and this 2i goes to there, this become minus 2i. So this is minus 6x items are normally four terms. This one, two, okay, one, two, and three. It's okay. Minus 6x minus 15y plus yi equal to minus 6i. Okay. Now simply, okay, real part is a 0, so I can write down this like this: 0 minus 6i. Now on equating real and imaginary part, we get minus 6x minus 15y equal to 0. This is equation 1. And second, imaginary part y equal to minus 6. Okay, this is y equal to minus 6. Put y equal to minus 6 in equation 1, we get minus 6x minus 15 into minus 6 equal to 0, minus 6 plus 90 equal to 0. Therefore minus 6 equal to minus 90. Therefore x equal to minus 90 upon minus 6. Therefore x equal to 15. Now they have asked us to find out x plus y. Now x plus y is equal to 15 minus of 6. Therefore x plus y is 9. Here is the end of exercise 1.1.